This demo introduces Cameo Enterprise Architecture version 19 and how Cameo Enterprise Architecture can be used to simulate missions. Missions defined in NATO architecture framework, UAF or DODAF. It's not really a big difference which framework is used. The underlying model is based on UAF profile. And the use case, the example that is demonstrated is search and rescue mission. High-level operational concept graphic diagram best displays what mission is used for simulation. So as we can see in this example, it is about boat in distress. So some accident happened for the boat. It sends distress signal to monitoring unit, which detects signal. Also, if the track information is not yet known, the helicopter will be sent to search for exact location, exact position where the accident happened. And once the position is identified, the live boat will be sent to help rescue people and of course, if possible, to rescue ship. The people will be brought back to shore where the ambulance will be waiting, and the ambulance will take people to place of safety. So this is the mission scenario. First of all, when we have mission scenario defined, we need to start defining the strategy of how we're going to perform search and rescue mission. Why do we need that, right? And the first strategic structure which defines the enterprise. So we are talking about search and rescue enterprise, which has the maritime phase called phase 2018. In this phase, there are specific goals, like for example, budget requirements. I'm going to show them in detail. Plus, there are also a set of capabilities that are exhibited within this phase. And here we have, as example, we have maritime search and rescue. Looking into capabilities tree, which is next, we see that maritime search and rescue belongs to UK search and rescue capability, which also includes land search and rescue, and all search and rescue capabilities, they include recovery, search, and assistance capabilities. Going further, there are also more detailed requirements defined for maritime search and rescue capability, like for example, mission cost, which is $30,000, or mission duration, which should not exceed 28 hours. There are also some other requirements, like there will be no casualties, so there will be no no dead people. Once we define the strategy, once we identify the capability and capability requirements, the next step is to describe how we are going to carry out the mission. And here we define operational scenario in a very abstract way. We define mission, identifying the main performers of the mission by not exactly identifying the resources that will be needed for the mission, but just trying to understand mission scenario and what information requirements are in place. Okay, so how, for example, search node needs to communicate with the place of safety, what information needs to be sent, and what are other parameters like security, bandwidth, other required for this specific communication. So the main focus here is to define, identify the main entities and the communication requirements between different entities. This, however, does not show the process. The process is defined in a separate diagram which shows how our different identified entities, so-called operational performers, are performing different operational activities. And we can see the very high level scenario, which is not intended for execution here. It's just to show and explain the main concept. However, this scenario can be animated just to validate if the diagram is modeled correctly. And the validation can be done by running simulation on this example. Okay, just slow down the animation and run the scenario, and you can see that the diagram so far is correct. And when we come to decision point, there is a question, for example, whether medical assistance is needed. If we say no, it's not needed, it goes the path where the medical assistance is not needed. Okay, and the scenario is finished. So if the diagram is more complex, we can validate the diagram. So then we can all agree that this is the desired behavior. This is how we see the mission to be carried out. And for the mission to be carried out, we need to define a solution. And solution is defined in the resources layer. It's a different layer of abstraction. Here we can define the multiple different solutions, and then we can run trade-off analysis. And we can see which solution is the best for the particular operational scenario. So now we're actually defining what. And if we go into the configuration diagram, which shows what are the resources participating in the scenario, we can see that all the resources that are modeled in this diagram, they have the life cycle defined in the state machine diagrams. Okay, and also we can see the interfaces between different systems participating in scenario. So we can see in details what information can go out via the selected interface, and what information then can go in on the other side of the connection into the other system. Okay. Also, state machines here, they are combined with activity diagrams. If I go to one state machine here for do behavior, there are activity diagrams that define the actions that are happening in the particular state. There is also different probabilities used to select which way we go. Different probabilities are here added based on some measures on the previous missions, but also different distributions can be applied, and Monte Carlo simulation can be run with a different distributions. In this example, it's a little bit simplified. We're not using Monte Carlo simulation. Here we use predefined values for probability. Also, on every action, there is a time defined, so that, for example, search for a big victim can take from 5 to 10 minutes. We go back to the main example. And in this scenario, we can see that there is a yacht. This is a boat in distress. Then there is a lifeboat, which is the rescue node. It implements rescue node in the operational scenario. Then there is also a mobile health vehicle, which implements place of safety in our operational scenario. Then we also have 2 helicopters. There's a primary helicopter, which is used for searching and identifying the precise position of the yacht. And also there is reserve helicopter, just in case if in a particular, at a particular point in time, if the boat in distress position is not identified, then the reserve helicopter is sent to help. Now, when we have all this scenario defined, we can also look into the overall traceability, where we can see that the search and rescue is made of different capabilities that then are exhibited by different operational performers, which are implemented by specific resources. So we see like aircraft, boat, helicopter, and so on. We can see all this information going out of traced back to the high-level capability. Okay. So now when we have all the configuration defined, we can run some simulations. There are different simulation configurations provided. I will start from maritime rescue, no UI, which means there will be no user interface here, just to demonstrate how this works. Let me open the configuration diagram before, some space. Okay, and when I run the simulation, I can see that all the systems participating in the scenario, they are in a specific state. Okay, they are all in the first state, like idle, for example, and now they're waiting for some events to occur within systems. And to do that, all we need to do is to go on a yacht and to send distress signal, and then we will see that our scenario is started, and there is a signal sent to the helicopter, and helicopter is searching. And once the victim is found, we will see that we will proceed to victim found state, and then also the message will be sent to lifeboat, okay, that to start rescue operation. While the simulation is running, we can also see the model at runtime. We see our maritime configuration, different parameters. We can see cost of the operation. We can see time. We can see also cost per hour, and we see if there are any casualties or not. Also, we can see what are the systems participating in this scenario that we simulate. Like, for example, lifeboat, yacht, mobile health vehicle, 2 helicopters, and also we can drill down and we can see the details of every different system playing part in the scenario. Okay, and this scenario is close to completion. We can see that now the people are rescued, and the ambulance is bringing people to safety, place of safety. And now we can see that scenario is finished. So the simulation is finished. The time for the simulation was 31 hours. The cost for simulation was $30,764. Okay. So now if we want to view the simulation from the different perspective, we can start a different configuration, configuration with timeline. Okay. So here we can study simulation from different perspectives. If I start simulation with a timeline, I can see the timeline open. Okay. All I need to do again is to trigger the simulation and send in distress signal. And I can see like primary helicopter, reserve helicopter, yacht, and other systems in the scenario. I can see which state they are. And also, I can see what signal and at what time forced to change state for a different system. Okay, like we can see that the reserve helicopter was required because the primary helicopter was not able to find the position for the boat in distress. We can also see that, so it's still searching. And we can see that victim was found, and the victim was found. The lifeboat is now in the rescue operation. Okay, and so this way, this chart helps you to understand what is happening at the specific point in time, and you can also see easily the time for every different action that happens in this scenario. Okay, so we can see that people were rescued, and the ambulance is bringing to place of safety. It is idle, so the mission is completed, and it took 40 hours for the mission to be completed. Okay, and the mission was successful because the yacht didn't sink. The other way to view the simulation is to run and record the simulation in the specific execution trace based on the sequence diagram. Let me start this configuration. This specific configuration starts with recording, with creating sequence diagram based on the different events occurring in our scenario. Again, to start simulation, I go select yacht, I click in distress, and as I can see, the simulation started. I can see in this distress signal sent from yacht to different other systems. And I can see that this scenario is further on recorded into sequence diagram. The recorded scenario can be afterwards used as the test case, or it can be used as to automatically trigger the simulation, capture the specific time, and also to perform analysis of what happened when. Because you can see timestamps at every signal sent. Plus, you can see how much time it was spent in every different state. At what time the state was changed. Okay, so now the simulation is almost finished, and we can later on, when we stop simulation, we can still analyze this diagram because it's created in the model and with the timestamp, so it can be stored in the model. And when we stop simulation, we still can explore and observe the diagram. Now, the other way to run simulation is to use user interface. User interface in Cameo enterprise architecture can be easily modeled using specific user interface diagram. So the user interface that I'm going to show you has no code associated to it. It's all modeled in the diagram, and then it can be launched as a desktop user interface or the web user interface. So we will start with desktop example. Let me run the user interface. Okay. So here in this user interface, I can see all the systems participating in scenario, like boat in distress, the rescue boat, the search helicopter, the reserve helicopter, and the ambulance. I can start this by simply clicking in distress button and sending signal to the system. And now I can see that the helicopter is searching. I can see the lifeboat is ready. And once the victim is found, once the boat in distress is found, we can see that the boat goes to rescue people from the boat. And we can see that the boat sank before the mission completed. And it's obvious that we're gonna have some casualties. We will see at the end when the simulation finish. We can see the mission duration, we can see mission cost, and we can see if mission is successful or not. So here we can see that mission duration already exceeded the given requirement. And we can directly see requirement from the UI. We can see that requirement ID 1, mission duration shall not exceed 28 hours, is not satisfied. We can see it indicated directly in the user interface. We can also see that the other requirement with ID 2, mission cost shall not exceed $30,000, is not satisfied as well. At the end, we can see that mission was not successful because there were some casualties because of the boat, of the sunken boat. Okay, so now we can stop the simulation and we can go to see how the user interface looks in the web interface. So let me start the simulation here. Okay, here I need to go and to look for the running web server address. Open it on the website, and here I can see the same UI with the same information, and I can again run scenario and see how how my mission is carried out. So I see that the helicopter is searching. I can see that the boat is in the rescue operation. The people were rescued. Now the ship is bringing people to shore where ambulance is waiting. The ship sank, however, all the people were saved. So the mission most likely will be successful. The people are on shore. The ambulance is bringing people to place of safety. Couple of more hours and the mission is completed. So it took 25 hours. It means that we are okay with our requirements. We are also okay with the budgetary requirements, and the mission is successful. So it's the perfect example of search and rescue operation. Okay, we can also analyze all this information directly here in the variables pane, which shows, as I mentioned before, the model at runtime. If we also think that this operation needs to be recorded, all the simulation that happened here, we can save the current state of the mission into the new actual configuration. Okay, and later we can open all the configurations, including the configuration that we just saved in the specific table, where we can see different configurations at different point in time. So we can see mission duration, we can see mission cost per hour, we can see mission cost, and also we can see if there were some casualties or not. So here we can analyze, we can set up automatic run of the simulation, so we can run simulation multiple times, and we can see finally we can see the distribution, and we can see how many missions were successful, how many missions failed, and what are the main factors for the mission failure. If we want to dig deeper, we can expand one of the missions, and we can see systems that participated in the mission, like the lifeboat. We can see how many hours the lifeboat was used. We can also see cost per hour, and we can see the total cost of the lifeboat in the particular operation. So we can also identify the bottlenecks where the problem was. Was that searching? Was that rescuing operation? Depending on that, we can make some decisions afterwards to improve our how search and rescue missions are carried out, or to change requirements for the next phase of the search and rescue, for example, for the next year. Okay, and this was a short demonstration of how missions can be executed in the systems of systems environment using UAF and Cameo Enterprise Architecture version 19. Based on the capabilities of the tool, many things can be automated, and at the end some decisions can be made based on the results of the different simulations performed. Thank you for watching.